So we are going to derive the quadratic formula by completing the square. First, we're going to take this generic quadratic equation. A, B, and C are all constants, different constants, and x is our variable. You notice we have it set equal to 0. We're going to complete the square on this, so the very first thing we want to do is divide each term by a. Because in order to complete the square, my leading coefficient has to be 1. This will give us x squared plus ba times x plus c over a equals 0. Of course, because 0 divided by anything is still 0. I'm going to subtract c over a from each side so that I can complete the square. This will give us x squared plus ba over x plus a blank equals negative c over a. This blank is so that we can add the constant we need to complete the square. So we end up with a perfect square. Now, to complete my square, I take this term next to my linear term right there. I'm going to pull it out, b over a, and I need to divide that by 2. Divide that by 2. I'm dividing fractions, so of course that's going to be the same thing as b over a times the reciprocal of 2, which is 1 over 2. So this is going to give me b over 2a. This is the term that I'm going to square and add in over here. So b over 2a squared is the same thing as b squared over 2 squared over a squared, which is the same thing as b squared over 4a squared. I'm going to add that to both sides. B squared over 4a squared and b squared over 4a squared. Now, over on the left side, I have my perfect square right here that I just created, and that's going to be x plus b over 2a squared. If you need to, expand this out and verify that that is indeed what it equals to. Now over here, I'm going to have negative c over a plus b squared over 4a squared. Now, this looks kind of messy. As math people, we're kind of fussy, and so we're going to write this as a single fraction. In order to do that, I've got to add these two fractions. In order to add fractions, I have to have a common denominator. So this denominator's a, this denominator's 4a squared. So I need to build up this fraction so it's an equivalent fraction with 4a squared as my denominator. So I would have negative c over a. I want to write it as an equivalent fraction with 4a squared as my denominator. So looking at that, I can see that I'm going to have to multiply my a times 4a to make it equal to 4a squared. And of course, if I multiply the the denominator by 4a, I must also multiply the numerator by 4a. This will give me negative 4ac in my numerator. Now I can substitute this back in up here, and I'm going to have x plus b over 2a all squared. That's the perfect square I made earlier, and that's going to equal negative 4ac plus b squared all over 4a squared. Looks a little neater. Now I'm going to extract roots, which means I'm going to take the square root of both sides. Square root of this side. When I take the square root of this side without the variables, I have to take the plus or minus, because of course a negative squared is going to result in a positive. This will give me x plus b over 2a equals plus or minus. Notice that the square root is over both the numerator and the denominator. I'm just going to write it as two parts right here so that we can simplify it as much as we can. So there's my numerator and my denominator. Now we can notice that my denominator is made up of a perfect square, so I can actually simplify that further. That's going to be plus or minus. My numerator has to stay the same. Negative 4ac plus b squared, because it doesn't have anything I can factor out. There's nothing I can do to simplify that. That should be plus or minus. And then I have, oops, darn. So we're going to try that again. So now I have x plus b over 2a equals plus or minus the square root of negative 4ac plus b squared all divided by 4a squared. Please notice this radical sign is over the whole thing, the numerator and the denominator. So I can rewrite that right side of the equation as negative 4ac plus b squared over the square root of 4a squared. And the denominator here simplifies because 4 and a squared are both perfect squares, so this can simplify to be plus or minus the square root of negative 4ac plus b squared over 2a. Notice here my fraction bar goes over the whole part there. Okay, now don't forget we've got over on my left side we still have x plus b over 2a. Now I'm going to subtract b over 2a from both sides, and I'm going to rewrite it so that I have x equals negative b over 2a plus or minus square root of negative 4ac plus b squared over 2a. Now you should notice these have the same denominators, so I can add them or subtract them. And this plus or minus means I really have two equations here, the positive one and the negative one. So I'm going to combine them, and I'm going to get x equals negative b plus or minus square root of negative 4ac plus b squared all over 2a. Notice the 2a is underneath the whole of the right side of the equation. This should be looking very familiar. I'm just going to rewrite this square root so that my positive symbol's first and my negative is second, so we don't lose that negative. And I get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This we should recognize is our quadratic formula. And we can use it to solve equations of this type. Any quadratic equation in standard form. Thank you.